Hey everyone, today we are solving LeetCode problem number 1582, spatial position in a binary matrix. So we are given a m cross n binary matrix and we have to return the spatial positions in that matrix. Okay, so what is a spatial position? Any position, let's say for ij, if matrix of ij is 1 and all the other elements in that corresponding row and column are 0, so that position will be counted as a spatial position. So let's say in this matrix, for this position, we have 1. Okay, first condition is true, and all the other elements in that corresponding row and column should be 0. So here we have 1, so it means this is not a spatial position. So for the other position, let's say for this one, if I equal to 1 and j equal to 2, this is the position. And here metric of ij is 1, which is visible to us, and for the other element in this row and column which are 0, it means this condition is also true. So this ij position will be counted as a spatial position. So how do we approach this problem? The first brute force approach came to my mind is like checking for all the position in this metric and comparing with this condition. So first of all we have to see for all the ones in this metric, because our condition start with 1. If metric of ij is 1, in that case we are going to check further. So first of all, check for all the positions. For all the value of I and j, we will see if metric of ij is equal to 1. Now we will see whether for ith row and jth column we have all the zeros in ith row and all the 0 in jth column except this position. So for that we can take a flag and check for every column and every row except I and j position. If at any position we encounter is 1, if at any position if we encounter 1, we are going to mark this flag as false, and in the end we will see whether this flag is true or not. If this flag is true, it means we have 0 in all the rows and all the column except this position, and that position is 1. So our condition is met and we can just count our answer. Okay, so this is going to be our brute force. In this case, we checked from all the positions. Let's say like we are iterating over this metric, so that is going to be n square, or maybe you can say m cross n time to traverse this array. And at every position, we are going to see whether there is all the 0 in row and column. So to check that, time complexity is m plus n. So in the worst case, we are going to see for all the ones. So that can go up to m into n into m plus n, and we are not taking any extra space in it. Okay, so if you analyze it further, like we are going to have a load of repeated work in this case. So let's say for this one we are checking for this row, and for this one as well we are checking for this row. So there is load of repeated work. So to avoid that, what we can do, so this is our condition, metric of ij should be 1 and all other elements in that row and column is 0. It means that for any one we have 0 in that row and column. So if we take sum of every row and every column, so what will be the value at ith row and ith column? That would be 1, because we only have a single one in that row and column. So what we can do is we can take sum of each row and each column. So for this row it is 1, this row it is 1, this row it is 1. With this column it is 2, this column it is 0, and for this column it is 1. And now we will see if any ij to be a special position, we have to see that value should be equal to 1, and the sum of each element in that specific row should be 1, and sum of each element in that specific column should be equal to 1. So in this case we are avoiding these repetitions, and but we have to take an extra space to store the sum of each row and column. For this algo as well, we are going to just iterate over our metric. Here, for every row and every column, if metric of ij is equal to 1 and the sum of that corresponding row and that corresponding column is 1, in that case, that is a spatial position and we have to count our answer. So in the end, we are going to have the number of spatial position we have in our metric. Return spatial positions. In this approach, we are taking time as m into n. We are just iterating over this array twice, and space complexity is m plus n. So we have improved our time in this approach. Okay, let's quickly code both of these approaches one by one. In the first approach, let's go with the brute force. In this case, we are going to check for all the possibility. Let's capture the row and column count first. M equal to mat dot length in n equal to mat 0 dot length and count to store our count of spatial positions. For each row I plus plus j equal to 0, j less than and j plus plus, and each column if mat of I and j equal to we can have only two values, either 0 or 1. If it is 0, we don't have to do anything. If it is 1, we will check for that corresponding row and column. To store our answer, we can just take a boolean flag. Let's say boolean good is equal to true in the starting. We will check for every column or maybe every row int k equal to 0, k less than m, k plus plus. In this case, for till m, we are checking for each element in that corresponding column. So for that, if k not equal to I, so the same position we are not checking again. Matrix of k, k means row, and j. If any other element is 1, in that case, good equal to false, we are just breaking the loop. And if there is any 1 in that corresponding row, we don't need to check for the column. So if row if that specific column is fine, if good equal to true, we can check for row now. Int k equal to 0, k less than n, k plus plus. If k not equal to that column and metric of that specific row which is I and column which is k is equal to 1. If there is any extra 1 in that specific column, we are going to mark good as false and break the loop. And if after all of this, if good is true, in that case we are going to increment our count, and after all of this we are just returning the value of count. Let's try to submit our sample test cases. There is one extra bracket, this is for 4. It should come after that. Sample test cases are passed, submitting the problem over this solution. Submitted successfully. And now we will check for the second approach where we were capturing the sum of each row and each column. And if it is a 1, it means there is only 1 in that specific row and column. Make another function, num spatial. Okay, in this case, we are going to capture m and n. Now to store the sum of each row and column, we are going to take an extra variable, extra array, integer row sum equal to new int m, int column sum equal to new int and because we have m rows and n column, we have already taken count. Now we will iterate over this array. Okay, for each row and column, we'll just capture the sum. Row sum I plus equal to matrix of I comma I and j, and column sum of j plus equal to matrix I j. Calculate the sum of each row and column. Now we are going to iterate over this array again, and we will see if that position is special position or not. Check for special position. For that position to be special, first of all the value should be 1, and row sum is equal to 1, and column sum j equal to 1. If this is the case, we are going to increment the count, and after this iteration we will have the number of special position that we can return. Let's test this. Submitted successfully. Okay, hope you understood the problem. Thank you guys.